Hey everyone, welcome to our second episode here at STEMI Physics for our mini series. And this is the second video for the introduction where we're going to be exploring physics as mathematics. So first up, I think it's really helpful to understand all the terms that we use when we describe math in physics. This is position, distance, displacement, speed, velocity, acceleration. These are the specific variables that we use for each one. It's important to know that the delta means the change in position. And when we have an arrow on top, like in displacement, velocity, and acceleration, we're talking about a vector. And of course, we're going to go more in depth of what that actually means, but it is good to have that in your mind. And each one has a specific meaning. A lot of these you have used in your daily life just when you talk about motion. They are more specific definitions when we come to physics. So the position is an object's position relative to another point. At this point, I recommend watching our previous video on reference frames and narratives because this is really where that comes in handy. When we talk about being relative to another point, that's basically defining your reference frame, so you know what it means when you're at 1, 2. And then we have distance, which is the amount of area actually covered by the motion. So that means if you travel 2 meters forward and then 2 meters back, the distance that you travel is 4 because it's the total area that you covered. The displacement is the difference between the initial and final position. So that means that if you move 2 meters forward and move 2 meters back, your displacement is actually 0 because there was no change in your position by the time you ended. Speed is the change of distance per unit time, and velocity is the change of displacement per unit time. A lot of times when we're talking in daily terms, speed and velocity are used interchangeably. But in physics, it's important to be more specific because speed and velocity, as you see here, have very different meanings. If we take the example before, that you move 2 meters forward and 2 meters back, your distance was 4. So therefore, your speed, if you took 2 seconds, is 2 meters per second. But your displacement, because you changed no position by the time you ended, is 0. So your velocity is also 0 meters per second. And acceleration is the change per unit time of velocity. And now we're going to go more in depth of what vectors and scalars are. So a scalar is a quantity which just has magnitude. So that's like saying 2 meters per hour. This can be added, subtracted, and multiplied and divided by each other because they're basically just constants. A vector is a scalar, but it also has a direction. So that's like saying 2 meters per hour to the north. That is a sense of direction. And a lot of times in physics, we do this by giving a positive or a negative sign. And vectors can also be added and subtracted, and they can be scaled by scalars, which is basically a fancy way of saying they can be multiplied or divided by scalars. And each physical property that we're going to discuss can be described as a vector or a scalar. And once we identify these things, it's really easy to solve, so we just get a better understanding of the movement. So now we're just going to go back to the exact same terms we saw before and talk about what type of quantity it is. So position is a vector. That's pretty easy to think about because if you look at a coordinate plane like we have in geometry, you can be at 1, 2. You can also be at negative 1, 2. So there's clearly a sense of positive and negative, and that's where you see the vector. Distance and speed are both scalar because if you go front or if you go to the back, it does not matter. It's just the total net distance that the total distance that you do travel. Displacement, velocity, and acceleration, on the other hand, are net. So that means it does take into account if you move forward, if you move backward. And that is what a vector is. And therefore, in these calculations as well, you can see the arrows as well as you can see in the variables assigned here, that they have the arrows and they are vectors. As we mentioned before, speed and velocity are the change in time, rate in time of distance and displacement. And acceleration is the velocity per unit of time. And therefore, the most common units for these are in the metric. So that's the meter, meter per second, and meter per second squared. And now we're going to look at some vector operations. And vectors are considered to be equal to each other if they have the exact same magnitude and direction. So that means 2 meters per hour north is only equal to another 2 meters per hour north. And a lot of times when we draw them using an arrow. And the size of the arrow is proportionate to the magnitude. And of course, the direction in which the arrowhead is pointed is the direction of the vector. And as I mentioned before, vectors can be added, subtracted, and scaled. To add and subtract, you line up the vectors up from tip to tail, just as you see in this image right here. So you can do A, and then the tail will match up to this tip and lines up straight there. And if you connect the lines straight through, that would be the total of A plus B. And using common math skills, you also know that A plus B equals B plus A. And that's exactly what this diagram is showing here as well. So if you put the B first, and then you attach A, you still get the same vector. And that's why it's really important to make sure that the tail is connected to the head. Otherwise, your calculations may get messed up in terms of direction. And for scaling, it's literally just multiplying each other or dividing each other. And if you get a negative, it just means direction. So it's just really multiplying and dividing by the scalar quantities. Thank you so much again for joining me on the second video for the introduction to the mini physics videos. Hope you enjoyed this video on mathematics, and next time we'll be talking about graphs. And make sure to like and comment on this video and check out all the other fantastic videos by Semi. Thank you.